So we're going to start with our conversions between radians and degrees. Remember, you have calculators for this entire exam. Your formula for this is degrees over 180 equals radians over pi. And unless I missed it in the mess of the front page of that one formula sheet, I don't think this formula is given to you. Okay, so this is one of the only ones that you will ever need to remember. Remember that when we are converting between degrees and radians, doesn't matter what mode your calculator's in because you are not using a sine, cosine, tangent button. You simply place the radians in place of radians and cross multiply. What happens to my pi's there? They cancel. And that means to find my degrees, I'm just doing 5/9 times 180, which gives me 100 degrees. If you are doing question 2 and flip-flopping that, you are just putting 350 in place of the degrees and doing x radians over pi. Remember, when we do those, we are not actually typing pi in our calculator. We're just going to reduce 350 over 180, which is going to give us 35 over 18, and you put your pi in your answer. And there's your radians. Okay. Some of the stuff I'm going to show you on this, we're going to go back and forth between the calculator. There are some things that I prefer to teach you what I consider the correct way when we go through it the first time, but the second time I'll show you some calculator tricks, because why not, right? You have everything on your calculator. Remember 3, 4, 5, and 6, these are right triangle problems where you're just using basic sines, cosines, and tangents. They've given you, I don't know why, a picture for a right triangle there, like you don't know what one looks like. But if you were doing question 3, using that picture, they've told you C is the right angle, B is 20 degrees, and side B is 35. Do we remember where side B goes in relation to angle B? Opposite, right? This one particularly says to find the rest of the parts of the triangle. However, most of them would just ask you to solve for one particular thing. For the purposes of just figuring this out, we're going to go through it. What's the easiest to find in the triangle right now?
Side C.
You can find side C using a sine, cosine, tangent, but angle A first would just be subtracting from 180. So that would be your first item is angle A equals 70. I would then decide whether I was setting up a sine, cosine, tangent based off of whether I wanted to solve for side C or side A first. It doesn't matter which one you do. Just for the purposes of argument, let's say we'll do C. From your angle 20, 35 is your opposite side and C is your hypotenuse, which means I would set up sine of 20 equals opposite over hypotenuse, which is what we're finding. In this case, you're solving for C before you type anything in your calculator, which means you are switching these two. Also, side note, what mode should we be in? Degrees. You will have to switch back and forth. Okay? All right, so if we type in 35 divided by the sine of 20, making sure we are in degrees first, that should give us our side C. After that, you do have options to find side A. You can set up another sine, cosine, tangent, or what else could you use? Pythagorean theorem. Just make sure you know which one is the hypotenuse so that you put the right one in the right spot. I got 102.33 for side C. If you did Pythagorean theorem, I would just do side C squared minus side B squared and then square root my answer, which then gives me side A is 96.16. Remember that a good check on yourself is that the largest angle should go across from the longest side. So you can just double check your answers to make sure they seem okay. Like those, when I get C, 102.33 sounds kind of large. However, considering side B is 35 when angle B is only 20, it's not that out of proportion. So I'm going to skip 4 and 5 because those are basically just the same thing. 6 is our first triangle word problem. If I am remembering correctly, in other years, there have been about 3 triangle word problems out of 20 questions, okay? We're going to go over the other triangle problems in depth when we get to them because they involve law of sines, law of cosines. One involves bearings. Yay, our favorite, right? But some of them are still normal triangle problems like you see in 6. In question 6, you've got a 20-foot ladder leaning against the side of a barn and an angle of elevation of 67 degrees. So quick review, where is an angle of elevation?
It's from the bottom and it goes up.
It's from the ground looking up. So my angle of elevation is down here. Our ladder is leaning against the side of a barn, which makes a right angle. Where do I label the 20-foot? The hypotenuse, which is the ladder, right? Find the height of the ladder, which means I'm finding which side? The short side over here, the right side. So again, this is just a basic sine, cosine, tangent. As long as you can draw your picture, you're good to go. From 67, you have the opposite in hypotenuse. So I'm setting up sine of 67 equals opposite over hypotenuse. And in my calculator, I'm going to type 20 times the sine of 67, which gives me about 18.41 feet. That 1 through 6 there is their basic review of our unit 6, where we did the unit circle and we started with angles and converting and right triangle problems. Then after that, we jump into the graphing stuff. We did this back in like February. The thing with the graphing stuff is that you have to remember this is a multiple choice test, right? So can they actually say graph this function as a question? I mean, they can, but what they have to give you as answers is multiple choice graphs, right? So again, going based off of my memory, in other years, there's been about 2 questions about graphs. I feel like there is one where they say, here is a function, what does the graph look like, where they give you multiple choice graphs. Oh, okay, that's fine. I'm recording, so you can get that. And then there's another question that talks about characteristics of a graph, like amplitude, period, phase shift, which if you don't remember that stuff, it's really hard to figure out, right? So first, graphing, remember you have a calculator. You do not have to graph something like this by hand. So if I had to graph something like question 7, what I would do is just grab my calculator, which I'll pull up here, and I would type in my function. One thing to remember is that the graphing part of your calculator should always be in radians. If it's not in radians, something is severely broken with your calculator and use a different one. The one thing that I really always emphasize when I talk about this is easy to type it in and play matching with graphs on your test. Here's what's not simple, and it is the zoom on their graphs. That's what you got to watch out for. So when I hit enter on this, that's all well and good, but remember sine functions can just be expanded or condensed. So if you're zoomed in on it differently, it can look a whole lot different than. So a couple characteristics of graphs then. We talked about amplitude. Anyone remember how to find amplitude? Okay, it's the number out front here, and it's also always what? So distance from the axis up to the highest point, and it's always positive as well. I will guarantee you on a question like that, they will have one that has a negative number out front, and they will have both an amplitude that is positive, that number, and negative. And it's going to be the exact same answer, only one would say positive 3 and one would say negative 3. Okay, so you need to know that amplitude is always positive. Second, period of the function. Anyone remember how we found that? 2 pi divided by what? B, whatever the B value was. In this particular equation, what is that B value? 1/2, because it's the number in front of the x, right? So that's like a 1/2. If I take 2 pi and I divide by 1/2 for a question like this, what's that going to give me for the period of the function? 4 pi. Of course, if you graph it, you can read it off the graph too, as long as you remember how to do that, okay? And then the other thing they could ask about is phase shift. Anyone remember that? We've talked about what that means. Okay, that's the plus or minus h. It's the horizontal shift. In the case of this particular one, there is none. If you flip over and look at question 10, 10 is a great question that I could see them using for all of those things. Because if I go through question 10, notice it has a negative a value out front, which requires you to remember that your amplitude is what? Always, or number 9, excuse me, not 10. On number 9, what would the amplitude be? 2, right? Yep, it's always positive. The period is 2 pi divided by b. Well, where's your b there? There is none, which means it's 1. So that means the period remains at 2 pi. And the phase shift in there is inside the parentheses, which is really which way? Right pi, right? Because we should know the direction that it's going in. It shifts at right pi because inside it's always the opposite of what it actually is. Okay?
So then what about the negative?
The negative is what does the reflection on it, but it doesn't actually do anything in terms of characteristics. Yeah. So 2 different ways I see those questions going. One is matching graphs, and one is just nothing to do with the graph itself, but just listing those characteristics. But that's about all I remember there being with graphs. The next part is where we did proofs. That's another interesting one to do in a multiple choice exam, mostly because you can't do proofs the way we did them, right? Because you're not showing your work. Okay, so I'm going to show you 2 different things for this. First, the right way would be to actually simplify that down to what it should be. So for a question like 10, what do we see that we could do? Okay, I can take those, secant squared plus cosecant squared, and what can I do with them? You can make them into fractions, right? You can make them 1 over cosine squared and 1 over sine squared, which then I went and I would have done the same thing here too, make that 1 over sine squared. What is this the same as? Secant squared, right? So then I'd go ahead and change that while I was at it. Those are multiplied. Any idea where to go from here?
Get common denominator.
You can get a common denominator if you want.
Multiply it all by.
Really, you can flip and multiply that. So I take the whole thing, sine squared and cosine squared over 1, and multiply that to the top, distributing. If I distribute both of those, in this fraction, the cosine squared is going to cancel. And that's going to give me what? Sine squared. When I distribute it to the second one, the sine squared is going to cancel, and it's going to leave me cosine squared, which happens to turn into 1. Okay, so it's great if you can get through it and do that. That's always going to be the simplest way. Now let me show you a cheat way on this. This is a multiple choice thing, right? So you're going to have multiple choice answers to this. It doesn't even matter what mode your calculator is in. You can just pick a number to plug in for all of your x's, okay? So let's pick a number. I'm going to change into, it doesn't really matter at all what mode you're in. Let's say I'm in degrees. Let's pick a degree to plug in. What's a good degree I can plug in for all my x's? 90? Now, the one thing I'm going to tell you is that I'm going to stay away from 0, 90, 180. Why do you think that is? Because some of those are zeros and you're going to end up with undefineds, and those are kind of funky. So I'm actually going to pick something like 15 degrees. That's not even in my unit circle. It doesn't actually matter. I'm just going to stay away from the ones that could give me undefined. You could do 10 degrees, you could do 5 degrees, you could do anything you really wanted. You can do pi over 4, you can do any of those, okay? Here's the thing. When you type it in your calculator here, Okay, the top of the fraction was secant squared plus cosecant squared. First things first, you know the notation where the squared is inside the secant or in the middle of it? You can't do that on your calculator. So when I do this, I have to do secant, let's just say I choose 15, and then I have to square it on the outside. Then I'm also going to do plus cosecant of 15 and square that. On the bottom, we had cosecant squared again of 15 squared. All right, so we see when we plug in random numbers here, it gives us the right answer out. If it was a function, you'd have to plug in the correct values. Using that same kind of logic, look at question 11. Let's just stick with 15. If I wanted to type in sine to the fourth plus sine squared times cosine squared, okay, they would have some multiple choice answers. So let me just make up some multiple choice answers to question 11 for you. They could have answer A, and I've written them here for myself so I remember them, is cosine squared. Answer B is tangent squared. Answer C is secant squared. And answer D is sine squared. So if I want to see which one that simplifies down to, the first thing I'm going to do is go ahead and type in sine of, again, just pick a number like 15 to the fourth plus sine of 15 squared times cosine of 15 also squared. Okay, this gives me a decimal. Not a nice one, but that doesn't matter. You're just going to go through your multiple choice answers. So we said we've got some multiple choice answers, cosine squared, tangent squared, so on. So I'm going to try the first one. All right, cosine of 15 squared. Same decimal? Nope. Try every single one of them. I happen to know what this one is. It is sine. If you check sine of 15 squared, answer D gives you the same exact decimal you had to begin with. Okay, now this is just kind of like a fallback thing, right? Of course, it would be best if we can just simplify and figure it out, but I'd rather you get it right, you know? So there's that. And of course, questions like 12, simplify without a calculator. Yeah, all right, well, they can say that all they want. It doesn't matter. Type that in your calculator, make sure you're in degrees, right? And make sure you get the same decimal. So for a question like 12, I would just type in sine of 42, cosine of, what was it? 38, okay? And keep on going through each of these. If I could remember each of them, that would be great. Cosine of 42, sine of 38. See what decimal it gives me and see which answer matches that decimal. In this case, I think your answer is sine of 4. It's either sine or cosine of 4. Yeah, it's sine of 4. So you'd have an answer that was sine of 4 degrees, and that would be the same exact decimal, which would be your answer. So there's a lot of ways around it if you can't remember how to do certain things. 13 and 14 are also like proofs. If you can get through them the right way, great. I hope so. You guys did very well at proofs, so I'm not concerned about it. But, again, you have your fallback method if you need it. 15 is the only question on the review that has to do with what we just did. I feel like there's a question or two on solving. Okay, hopefully we know how to solve because we've just taken a test on that. Quick reminder on 15. How do we get sine by itself? Divide by 4 and square root. Now, something some people forgot on the test, when you square root, plus or minus, right? Okay, so I have plus or minus a half. Remember, you've got that filled out unit circle on your chart? And if you remember the sign is the y values, you're just looking around the circle for where sine has that y value. So that's going to happen at pi over 6, 5 pi over 6. 7 pi over 6, and 11 pi over 6. These are other good questions for plugging in your answers. Okay, what mode would you have to be in for this one? Radians. So if I wanted to see if this worked, I would make sure my calculator was in radians. And I would type in 4 times the sine of pi over 6 squared. Remember, the sine is the only thing that's squared, not the 4. And according to that equation, I should get 1 back out. So you would check every one of your answers and make sure they worked out to the correct equation. Okay? That's a very, very easy one to type in your calculator. All right, now, here's what we tend to forget because it's been forever and we also don't love it. Law of sines, law of cosines. This is this chapter 7 stuff. When we do law of sines, law of cosines, first off, we make sure we are in degrees. Okay, secondly, we need to remember in which cases we can use each one. These are on the back of the formula sheet that has all the stuff on it. Law of sines is on there. A couple versions of law of cosines is on there. So there's nothing you have to memorize from that. Just a quick review. 16, I can use law of sines because I have an angle side pair, right? So I start out with sine of angle A over our missing side A equals sine of angle B over side B, and I just cross multiply. In this case, 100 times the sine of 40 divided by the sine of 12 gives me side A is about 309.16. What's the next item we can find? The next angle, because they all add up to 180. So angle C is 180 minus 12 minus 40, which gives me 128 for angle C. And then we find side C. Again, I would probably use angle B and side B because those were given to me. Sine of angle C over side C and cross multiply to find that. One thing that I am going to remind you of on these kind of questions is a lovely phrase that we all hope to forget. I'm going to say it. Ambiguous case. I have a vague recollection of a question that involves this. And vague meaning I'm not sure if the question was actually an ambiguous case one, but they made the answers potentially ambiguous. Some of the answers had a possibility of 2 solutions. Remember the ambiguous case? When did it happen? Okay, you've got 2 sides and an acute angle. So obviously none of the things that they've given me here very nicely, right? If you look at one of these questions and in their answer choices they say side C is this or this, that's ambiguous case, right? So remember, if we were to do that, and I will just make up something real quick. Let's say in 17, I'll just make angle C be 20 degrees. I don't know. If I make angle C there 20 degrees, then that's a potential ambiguous case. You're given 2 sides and an acute angle. So you would start off by saying sine of angle A over side A equals sine of angle C over side C. And I would cross multiply that. 5 times the sine of 20 divided by 20. And because I'm finding angle A, what do I have to do? Inverse sine. Here's where the ambiguous case comes into play. Angle A is, in this one, 5 degrees. You have to check for another possibility for angle A. How do you find that other possibility? Subtract it from 180. Now, quite frequently it doesn't actually work, which is in this case. Can angle A be 175 degrees? No, why not? Okay, it's the smaller side. Also, I already have an angle that's 20 degrees. If that one's 175, that's already over 180. Not possible, right? So that's how we check for the ambiguous case. It frequently doesn't work, and then you just finish it up with the stuff that you were given. Okay? So even if they have the option for it, sometimes it's not. But you do have to check. 18 is a good example of the law of cosines. How do I know in 18 I'm using law of cosines?
It gives you all sides.
All sides, right? And if we would like to avoid the ambiguous case and be nice to ourselves, what angle do we solve for first in law of cosines? The biggest one. So I would use the version using angle B, which means I would set up 53 squared equals 49 squared plus 38 squared minus 2 times 49 times 38 times the cosine of B. This is not a complicated question either. However, we sometimes forget how to solve these, right? So if I'd like to get angle B by itself, what do I have to move? All the squared terms to the left. So I'm going to start by doing 53 squared minus 49 squared minus 38 squared. This gives me negative 1,036 is equal to negative 2 times 49 times 38 gives me negative 3,724 cosine B. Then I divide. I get a lovely fraction. I don't actually know if that reduces, but it doesn't matter because I'm just going to use it to find the angle by typing in what? Inverse cosine of that fraction. This gives me angle B is about 74 degrees. Then you may proceed after that using law of sines. I'm not going to finish it out because it's just more of the same. Now, 19 is the first time we're seeing something that we didn't really talk about in class. There are ways to do 19 using what we've talked about, but there is an easier formula. We just don't have a whole lot of application for it in class, which is why we completely ignored it till now. So if you flip to the back of if you flip to where law of sines and law of cosines is, there is something called Heron's area formula. This will be something, or historically, has been something on the test. Okay? Heron's area formula has two parts to it. The second line underneath it has this constant S. S is nothing other than something used in the formula. And then the area formula itself is this thing. The reason this formula exists is just because sometimes you don't want to have to like drop down the height and find what that is in order to find the area of the triangle. So they made up this formula, or someone figured it out, so that you don't have to find the height and you can just use the three sides. So when you use Heron's area formula, the first thing you do is find this constant S by adding your three sides together and dividing by 2. So this gives me, for this particular problem, 7.5. So in that area formula, anywhere I see the letter S, I'm using that 7.5, and I'm simply plugging that in with the three sides. So in my calculator, I'm going to type in all at once the square root of 7.5 times 7.5 minus 3 times 7.5 minus 5 times 7.5 minus 7. Also, this is literally all there is to this area formula, so you can tell why I don't actually spend the time to do a whole lesson on it. Not real difficult. It's more of a plugging in thing. Though it is a nice SAT thing, or ACT, for those that are still taking it. I get around 6.5 for the area. Okay. For our first word problem here, this is kind of the worst of them. It's lovely. And if they didn't give you the picture, it would be really not nice. So, here we are. We've got a passenger in an airplane flying at an altitude of 37,000 feet. We have two towns due west of the airplane with two angles of depression. Notice 32 is that top angle from straight across looking down. Remember, angles of depression are from the air looking down. And then 76 is the entire angle from the top down to the second dotted line. I don't love in this picture that it looks like the 37,000 isn't making a right angle with the ground, but it is. So the first thing I do in this is identify what they're trying to get me to find, which they want to know how far apart are the towns, which in this case is where? Along the ground. From here to here, we're going to call that our x. After that, on a picture like this, I'm just labeling anything I can find. Okay, sometimes the way it's set up, it doesn't make sense right now, so I just start putting labels wherever I can find it. The 37,000 is the height of the plane here, so I can put that in right there. What else can I label in this? Or find?
The angle on the inside.
The angle on the inside, if 76 is the whole thing from here to here, that means this angle in here is 44. What else? There's two more obvious things to me.
Like the at the top for that second, like for that triangle.
Mm-hmm.
37,000.
Yes. Okay, you can drop the 37,000 down here too. This is a 90-degree angle there, which means I can find this other angle over here from the 32. 90 minus 32 would give me, this one was 58. Another geometry thing is that you can take that 32, the angle of depression, and drop it into this triangle. All right, so with that, you then kind of have enough information to get started. Like I said, sometimes you're just labeling a bunch of stuff till you can figure out where to go. I start in this triangle here. What side in that triangle could I find that would help me on the inside? The hypotenuse. We'll call that H. I was looking from this 32 degrees because I didn't necessarily label the 58. But from that 32, I could say sine of 32 is equal to 37,000 over the hypotenuse. Just like the previous question we solved, you can switch these two. The height is 37,000 divided by sine of 32. Or the hypotenuse, not the height, excuse me. So 37,000 divided by sine of 32. Again, these are large numbers, and this is across from the right angle. So that should make sense. What you're getting out of this is a large number. Gives me about 69,822. Is that what we got-ish? Okay. After that, I then worked with this inside triangle. Can I use basic sine, cosine, tangent in this triangle? No. There are no right angles. We can find the third angle very easily by subtracting 180 minus 44 minus 32. And I can use what law to solve for the side that I want? Sine. I'm going to go ahead and set up sine of 104 over that 69,822 that we just found equals sine of what angle are we going to use to find
44.
the 44, right? 44 over x. 69,822 times the sine of 44 divide by the sine of 104. And I get about 49,987.3. If you look at the answer key to this one, this is not the answer they have. It doesn't say specifically in the problem to find the answer in miles, but that's what they did on their key. So they took this number divided by 5,280 feet in a mile. I don't recall that being an issue. And that's where they got the 9.47 miles that they had. Okay. Now, that's probably a more rotten word problem. If I am remembering correctly, there is one question that I feel like if you miss it, I'm not angry, because there are ways to legitimately miss that question. Like, you draw the picture wrong, you do something like that wrong. It happens. I don't think it's impossible to get it right, but I just think if you miss it, I'm like, well, yeah, no, like, I get that. There's a couple other word problems that if you do miss them, I'm a little bit on the angry side. For example, 21. A question like 21 should not be missed. Yes, it's a word problem. Is it hard?
It's just low.
It is not actually hard, right? The angle outside is 80, therefore the angle inside is 100. You can just use law of cosines. Excuse me. Okay, so very easily on this one, I would set up b squared is equal to 240 squared plus 380 squared minus 2 times 240 times 380 times the cosine of angle B, which is 100. Literally type the entire thing in your calculator and square root, and that's it. So don't think all word problems are going to be awful and skip them just because they're word problems, right? Especially when it's a 20-question test. At least, again, historically. Never seen a different one, but who knows? So in this case, if I type that all in my calculator and square root, I get about 483.40 meters. The last word problem we will go over is 22. All of our favorites, bearings. Woohoo! That's the kind of question that if you miss it, I'm not like super angry at you. This one is not bad. I hope this is similar to the one on the test, but we shall see. On question 22, we've got two ships leaving the port, so they're both leaving the center of our graph here. One travels with a bearing of north 53 west. What quadrant is it in?
1 or 2.
2. North 53 degrees to the west. So that means my ship is headed off this direction. Where is the 53-degree angle?
It's between.
Between north and the purple line for my ship. This is the 53. Now, frequently when they give me that, I like to find the one next to it because why not? You might need it. 37. Our second ship is traveling at a bearing of south 67 west. Which quadrant is this one in? The third. And where is that 67-degree angle? Okay, between south and orange. If that one is 63 or 67, the other one is 23 in here. We would like to know how far apart are they, which completes our triangle right here. So it does matter that I know that 37 and 23 because that tells me this interior angle here is 60, right? Here's the other thing that comes into play in the same question. No, because when it says south 67 west, it means start south and then pull it 67 degrees towards the west. So the 67 has to be outside. The other thing that comes into play here is the speed versus the distance. They've told me the first one's going 12 miles per hour. The second one's going 16 miles per hour. If you read the question carefully, they have each traveled for how many hours? 3. Therefore, the first ship has gone 36, and the second one has gone 48. Now, after you get the picture labeled, it's the exact same as the previous question. Use a law of cosines. B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. Just type that in and square root it, and you will be good to go. Okay. All right, any issues with your word problems? Like I said, I feel like there's about 3 triangle word problems. Just plan on it. Save your time for those. Okay, I can't help you set them up, unfortunately, but good luck, right? Last couple questions are on vectors. Vectors is that second formula sheet. The trick to the second formula sheet is that like next to nothing is labeled. You need to know what things are on it, okay? So when question 23 asks me for the magnitude of the vector, I need to be able to look at this sheet and remember which one is the magnitude formula. Any recollection of that? Second one, the one with the double bars and the square root of x squared plus y squared, right? This question 23 actually uses both the first two formulas. The first one because it gives me an initial point and a terminal point. So to find component form, I have to do x2 minus x1, y2 minus y1. That gives me the vector 2, negative 15. Once I have my vector in component form, then I can find the magnitude. Square root of x squared plus y squared gives me the square root of 229. They might have it in decimal form, they might have it in square root form, but again, you have a calculator, so if you just match decimals, you can figure it out, right? Any issues with that? Again, I feel like there's like 3 questions on vectors. They're very easy. They should be the easy questions, but again, you got to remember what formula is what. Dot product formula in 24, any recollection of which one that is? Okay, the dot product is the one directly under 7.4 with u dot v, right? I have a very specific recollection about a question that just asks you to find a dot product. Now, it does not say the word dot product. It just says find u dot v, okay? Again, remember the dot product of u and v simply gives you a number back out. It does not give you another vector. Negative 9 times 1 plus 4 times 2 gives me negative 1. That is it. Don't make those complicated. 25, angle between the vectors. Again, not labeled on our formula sheet here. Which one is it? Last one, the cosine theta one. In order to find the angle between the vectors, we need 3 different things according to that formula. We need the dot product, and what are the 2 things on the bottom there? The magnitudes of both of them. Also, notice this one is thrown in this nice notation too. Remember when we talked about that? This simply means this is the vector 7, 2. What is vector v? 0, negative 4. Notice how there's no I part? That means the x is 0. So I'm going to start going through the things that I need to find for the angle between them. I need to first find their dot product. So I'm going to do 7 times 0 plus 2 times negative 4. This gives me negative 8. I'm going to find both magnitudes, the magnitude of u and the magnitude of v. Magnitude of u is 7 squared plus 2 squared, or square root of 53. Magnitude of v is square root of 0 squared plus 4 squared. That does simplify to just 4. You can leave it as the square root of 16 if you want. Totally up to you. Then to find the angle between those, I set up cosine of theta is equal to the dot product over both of your magnitudes multiplied together. To find the angle, how are you going to type it into your calculator? Inverse cosine of that fraction, making sure you're in degrees, because you want an angle in degrees back out. I put the 4 in front of the 53, root 53, mainly because sometimes if you don't remember to get out of the square root, you'll put the 4 underneath it accidentally. So I would say be careful with that. I get about 106 for this. And last question on here. We have one extra thing to talk about that's not on here. Last question on here, are these orthogonal or perpendicular? First thing on this question, they don't put perpendicular in parentheses on the test. They just ask if they're orthogonal and expect you to know what that is. Okay? So just mental note there. Second thing, what is the easiest way to tell if these are perpendicular? Slope. Every vector starts at 0, 0, so that means the slope for u is negative 12 over 9, the y over the x. What does that reduce to? Negative 4 over 3. For vector v, It's negative 3 over negative 4, and two negatives make a positive. Are these opposite reciprocal slopes? Yes, therefore they are perpendicular. Okay? Now, there is one thing I've told you before that I know this is on there, and I don't teach it because it has 0 point to it. It involves the back of this vector sheet that says trig form of a complex number. Feel free to write this down somewhere, but I've pulled up 2 multiple choice questions here that have to do with this to show you what the heck is going on without teaching you the actual thing. Okay? So this example that I've shown up here says express the complex number in trig form. I could go into a lot of reasons why I don't show you how to do this. The main reason is in 8 years of graduate and just regular college in math, I've never used this. Also had to teach myself what this was when I began teaching this class. So, not necessary to any of your future endeavors. If you are given a multiple choice question like this, you don't even have to be able to use the formula. You just have to plug in what you know. So let's take a look at our answers here. None of this makes much sense to me, other than I know what this is, and I know what this is, right? Can I find the cosine of 270? Mm-hmm. Yep. What is the cosine of 270? According to my chart, unit circle? 0. What is the sine at 270? -1. So far, I took that answer and I just plugged in numbers for cosine at 270 and sine at 270. Numbers you should know how to find, right? Let's distribute this 5 and see what we get. 5 times 0 is 0. 5 times negative I is negative what? 5i. Is that what you need to get up here? Yes. Now, we got it on the first one, but I'll show you the other ones real quick. This one, I would check this answer and say, what's the cosine at 180? Well, the cosine at 180 is -1. The sine at 180 is 0. If I do the same thing there, what's this going to simplify to? -5. Not the right answer, right? Third one, cosine at 90. What is that? 0. Sine at 90. 1. What's this going to simplify to give me? 5i. Again, not the right answer. Last one. Cosine at 0 is 1. Sine at 0 is 0. What's this going to simplify to? 5. So you just plug in what you know on all of the answers till you get the right one. Literally. Okay? You don't actually have to know how to find these. I'm going to show you one more like this just because it's a weird thing. And I want to make sure you know how to do it. One question total. Same type of thing with this one, only it's in decimal form. Okay. So, or there's 2 different ones here. In this case, if it's in decimal form, I would find the cosine of 5 degrees in my calculator. And I would get a decimal for that, see what it works out to. So cosine of 5 degrees gives me the decimal 0.996 plus I. Sine of 5 degrees gives me the decimal 0.087. And I would distribute that 4 and see whether it's going to be closer to this answer or that answer. If I distribute 4 to 0.996, that's pretty close to 1, right? So 4 times something pretty close to 1, is that going to be 4 or is that going to be -2? If I distribute that 4 in. Not going to be -2, that's for sure. So you'd get an answer that looks like that. All right? So it's literally just plugging in values for these. Don't make them too difficult. You don't have to know any formulas for it. The first question is more like what I've seen than this one, because it's typically values out of your chart in unit circle. Okay? And that is it.